looking to find all 6 trig functions for an angle if you're given a point, this is how you would proceed. The point that we're interested in here is -2,5. So that means we're going to go back 2 units and then up 5 units. 1, 2, 3, 4, 5. All right, so we're going to that point right there. Okay, so we're making a triangle, and the triangle is going to connect directly to the origin. So we have our hypotenuse, and then we are either going to draw a vertical line down to the x-axis or up to the x-axis if the point is below the x-axis. So this is our triangle right here. Now theta, which again is like x, only it's one of the Greek letters, theta is located in between the x-axis and the hypotenuse. So that angle right there is theta. All right, we want to find the 6 trig functions. Okay, the first is sine, the second is cosine, the third is tangent, and then we have their reciprocals, which are cosecant, secant, and cotangent. So we really just need theta afterwards, because you have to take the trig value or the trig ratio of an angle. Right? And we really just need the first 3, because once we get these 3, the next 3 are just the reciprocals of the first 3, so we just have to flip them. All right, so there's our fraction bars. Now, what's happening? Well, we need some numbers here. Okay, if we go to our triangle, we have the 3 sides. We have the opposite, the adjacent, and the hypotenuse. Now, the opposite of theta, that side we know is 5 units long because we go up 5 blocks. The adjacent side is 2 units long. Okay, however, we're going to think of it as a -2 because we went to the left of the y-axis. So we're going to think of that as like -2. And then the hypotenuse, we have to use the Pythagorean theorem to calculate. So the hypotenuse, which is right there, we know that's c squared, which is equal to a squared plus b squared according to the Pythagorean theorem. Right? A and b are 5 and -2, so we have 5 squared plus -2 squared. Right? 5 squared is 25, -2 squared is 4. So when we add those together, we get 29. So that's the square of the hypotenuse, which means that the hypotenuse is the square root of that, square root of 29. And we can leave our answer just like that. We don't have to try to approximate it. Just leave it as its exact value, which is the square root of 29. It's a number that's a little bit more than 5, a little bit less than 6. Now we have our opposite, adjacent, and hypotenuse. So let's go ahead and put them into the fractions. Now from the first part of the class, you wrote down what the sine fraction, the sine ratio is equal to. We know that sine is equal to opposite over hypotenuse. All right, I'm just going to write that really quick over here. Opposite over hypotenuse. So opposite of theta is 5. The hypotenuse is the square root of 29. So we have 5 over square root 29. And that's it. That's all we have to do for sine. Now we go to cosine. Cosine is adjacent over hypotenuse. So the adjacent is -2, and the hypotenuse is square root of 29. So -2 over square root of 29. Tangent is the opposite over the adjacent. Opposite is 5, adjacent is -2, so we have 5 over -2. Now these 3, cosecant, secant, and cotangent, as we already mentioned, are just the reciprocals of sine, cosine, and tangent. So all we're going to do is flip the fractions. Cosecant is the reciprocal of sine. It's hypotenuse over opposite. We flip this. So if we flip these numbers, we have square root 29 over 5. And cosecant is done. Secant is the reciprocal of cosine. So let's flip this fraction. Square root of 29 over -2. Cotangent is the reciprocal of tangent. So when we reciprocate 5 over -2, we get -2 over 5. And we now have all 6 trig fractions. We've completed the problem. So this is what I'm looking for you to do on that assignment for today.